Everyone. So this is kind of what we're working on today. First, I want to show you the lab safety quiz. Again, this is on Canvas. I don't have your class set up yet because I can't. I don't have your class yet. But this will be in Canvas. This will be literally the questions that you're going to get. This is going to be the exact quiz. And then if you scroll down, you'll have all the answers. So please, 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 please study the answers so that you can get that 70% so that you can do labs. Okay. Really, really important. Other than that, I'm going to walk you through activity atoms versus ions. So this is going to help you to use the periodic table to help you and then also extract some other information. So let me go ahead and show you what that looks like. This is the document that you're going to have. And then there's a periodic table here that you can use online, or you also have a paper copy or a laminated copy in class. So I'll kind of hold this up for you so I don't have to toggle back and forth. Okay, and there's some definitions of cations and anions here. And also just showing you what like ion symbols are. So I'll come back to this in a moment when we need it. And then there's going to be a drawing portion here. This is obviously a paper drawing situation, so I will kind of describe what you should do, but I can't do it physically on here. Okay, so the first thing is the atomic number. And if you look at this, I don't know if this will be in reverse or not, but there's a little key here, and it tells you that the atomic number on the periodic table is on top. So you can see the atomic number is the top number there. And it also tells you that the bottom is the average atomic mass. Both of those are going to be helpful bits of information. Okay. So this first one is asking us about on your screen about lithium, right? Yeah, lithium. So we're going to find that on here. And that is, sorry, doing this in reverse. That is right here, lithium. So we look at that top number there and it says 3. That's going to be the atomic number. So I'm going to put that right here. And here's the cool thing. If that is true for the lithium atom, it's also true for the lithium ion. The atomic number is very, very, very important. The atomic number is the thing that defines the element or the atom. So no matter if it's an ion, an atom, an isotope, whatever, that's going to be true that the atomic number is going to be that exact number. What's also cool is that that has to be the same as the number of protons. That's what actually defines it. So I can go ahead and put a 3 there as well as right there. Okay, so protons are always the same as the atomic number. These are definitely things I would encourage you to put in your knowledge organizer. Okay, those are always, 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 always the same. Now, for our mass purposes, what we're going to do is we're going to take the mass from our periodic table in this case. That won't always be the case, but in this case, we're going to take the mass and we're going to round it to the nearest whole number. Okay, so this is 6.94. The nearest whole number is going to be 7. Okay, so that's our mass number. And that is true of both the atom and the ion. Okay, mass numbers are going to be the same for the atom and the ion. The nice part about neutrons, and notice that protons and neutrons are the thing that are in the nucleus. Okay, protons and neutrons. Protons positive, PP. Neutrons negative. Neutrons neutral. Neutrons neutral. Okay, they don't have a charge. And I get the mass. Oops, I forgot to even delete it here. I get the mass by get the neutron number by taking my mass minus my protons. So 7 minus 3 gets me my neutrons. 7 minus 3 gets me my neutrons. Everything so far is the same, you guys. Everything. Okay. Now, I'm first going to focus on my atom because the ion will be a little trickier. So I'm going to first focus on this. And for atoms, remember that we talked about that cathode reactivity, that green thing that was shooting through was neutral, that like the Dalton model of the solid sphere we thought was neutral. If it's neutral, that means that it should have the same number of positives and the same number of negatives. So I see here 3 positive protons. That means I have 3 negative electrons. Okay, so again, for the atom, those are going to be the same as each other. Protons will be the same as electrons for the atom. You might remember from the PhET activity that electrons are the things that go in the ring. Hopefully you remember from the PhET activity, and if not, this would be a good thing to write in your knowledge organizer to help you in the future, is that the very first energy level, the one that's closest to the nucleus, can hold up to 2 electrons. The ring after that, the orbital after that, can hold up to 8 electrons. And then the next one out as well, 8. It gets more complicated than that, beyond that. But for right now, 2, 8, 8. Those are our magic numbers. So I need to place 3 electrons. Okay, so I'm going to put my first 2 in my first energy level. So like boom, I can't do it, but you get it. I'm going to do like a dot here and a dot here right next to each other, like as if that's the only ones that they can hold. So dot, dot, that takes care of 2 of my electrons, but I have 1 more to go. So I'm going to go to the next energy level and I'm going to put 1 there. So it'll be 2 dots in the center ring and then 1 dot in the third ring. Okay. That's what the atom, the lithium atom, would look like. Now, for the lithium ion, ions are different. Ions like full shells. That's the key with ions. They like to have full energy levels, okay? Remember we said that full for this inner one is 2, full for this one is 8, and full for this one is 8. So currently, if we were looking at the atom, remember we said we had 2 and 1. So if the max that this one can hold is 8, then you want to ask yourself a question. Is it easier to add 7 more to this energy level in order to fill it up? Or is it easier just to remove that 1 electron that's there and then we jump down to this energy level and now this energy level is full? So the question is, gain 7 more to fill up this energy level or lose 1 to have this energy level be full? I don't know about you, but losing 1 sounds way easier than gaining 7. So that is exactly what we're going to do. We're going to lose 1, and that leaves us with a total of 2 electrons. Both of those electrons are in that first energy level, and that makes that first energy level full. So remember, the key for when you're drawing your ions is making it full. That's probably the hardest part on this activity. So if you need to, do all the other stuff first, okay? Do the entire column here, the entire column here, fill out what the atoms look like, and then you can always come back to this and then remember, oh, it needs to be full. What's easier, gaining blah, blah, blah to get to 8 or losing blah, blah, blah to get to whatever, okay? So that's what I would recommend for that. Now, the last is this cation and anion part. Now, remember, I have the definitions up here. Cations, it says, has a positive charge and it lost electrons. And anions have a negative charge and it gained electrons. Well, let me see what happened. First of all, I see the little symbol here and it has a positive 1, positive charge. I'm going to say that's a cation. Now I can also double check. Did it lose electrons? Yes, it went from 3 electrons over here to 2 electrons over here. It lost an electron. So I've confirmed by both ways that this is indeed a cation. So that's what I'm writing there. And remember, you are doing this on paper. All right. I do have a key. So depending on if I'm there or not, or if it's available, you can try to check your key, but you can certainly ask me as well. So try this on all the other ones you've got provided. Thank you.